let's re-examine the comparison problem. 100 to the 99th power and 99 to the 100th power, right? See which number is bigger, right? This time we're going to use some basics of calculus to compare these two numbers. So what we're going to do is that first we are going to take a natural log of these two numbers. So the natural log of 100 to the 99th power and the natural log of 99 to the 100th power, right? See which number is bigger. The reason that we can take a natural log of those two numbers is because the natural log function is actually monotonic, so it's going to preserve the ordering of numbers. So if this number is smaller than this number, then the natural log of this number is going to be smaller than the natural log of this number, and vice versa. So it can be simplified to 99 times natural log of 100 and compare with 100 times the natural log of 99, right? And at this point we can actually do a division. So we can use this number to divide this number and compare the division and compare the ratio, see if it's smaller than 1 or bigger than 1, right? So that's 99 times the natural log of 100 divided by 100 times the natural log of 99, right? And then compare it with the number 1, right? See if it's larger than or smaller than 1. And the number over here can be written as the natural log of 100 divided by the 100, right? Natural log of 100 divided by 100, and then divide the natural log of 99 over 99, right? And then compare it with 1, right? And this comparison, comparing with 1, is actually equivalent to what? It's actually equivalent to comparing natural log of 100 divided by 100 and compare it with natural log of 99 divided by 99, right? At this point we can define a function called fx. So fx is going to equal to x natural log of x, right? So comparing these two numbers is equivalent to finding out if this function is increasing or decreasing from 99 to 100, right? So if the function is actually decreasing from 99 to 100, then this number should be smaller than this number, right? Because 100 is bigger than 99, and the function is decreasing, right? So f100 should be smaller than f99, right? And if the function is increasing, right, then this number should be bigger than this number, because f100 is going to be bigger than f99, right? So how do we find out if this function is increasing or decreasing from 99 to 100, right? So at this point we can actually take a derivative. So if the derivative of this function is positive, it's larger than 0, then this function is increasing. But if the derivative is negative, right, it's a negative number, then the function is decreasing, right? So how do we actually evaluate the derivative of this particular function, right? Here we have to use a fundamental equation. Suppose a divided by b, we want to take a derivative of the whole thing, then it's going to equal to b squared, right? A derivative times b subtract a times b derivative, right? So this is one of the fundamental equations in calculus, and we can use it, right? So f prime x is going to equal to x squared, right? And then a prime log x, right? So log x, natural log of x, take a derivative with respect to x, that's going to be 1 over x, right? Times b is x. Subtract a, which is log x, right, times b prime. B is x. X take a derivative with respect to x. That's 1, right? Times 1. So we end up with x squared on the denominator, and then 1 subtract natural log of x, right? When x equals to either 99 or 100, the denominator is always going to be positive, right? The question is the numerator. Is the numerator going to be positive or not negative, right? So we're basically comparing log x with 1, right? The natural log of x, if it's larger than 1, then we have a negative derivative. Otherwise, we have a positive derivative. How do we know if natural log of x is bigger or smaller than 1, right? We have to compare x with e. So if x is larger than e is 2.7 something, right? Which is actually the case for 99 and 100. Then f prime x is what? F prime x is going to be 1 subtract log x, right? X is larger than e, so natural log of x is going to be larger than 1, right? 1 subtract a number that's larger than 1, that's going to be a negative number, so f prime x is going to be smaller than 0, right? If f prime x is smaller than 0, which means fx is a decreasing function, right? It's a decreasing function in the neighborhood of from 99 to 100, right? It's a decreasing function, which means what? Which means f 100 is going to be smaller than f 99 because it's a decreasing function, and 100 is larger than 99, right? And that means what? That means so this circle is going to be smaller than, right? So this is f100, this is f99, so it's going to be smaller than that, and this is going to be smaller than, right? And then this is going to be smaller than, and the same is true over here, the same is true over here, and then this is smaller than, right? So we have obtained the solution. This 100 raised to the 99th power is smaller than 99 raised to the 100th power, and this conclusion is actually the same as the previous video. We actually solved it using a simple arithmetics.